Yo, okay, so I think we're back. Sorry for that. The Twitter seemed to have disconnected. If you're on Twitter, if you're joining from X, can you just give me a comment below if you're joining from X and you can see this? Because yeah, there seem to be some issues. There seem to be some issues. I think you guys from X, is there people from X? Is it working? Is it coming through? Oh, I'm gonna try it one more time with. I managed to connect the wallet as well when I was offline. So I'm gonna try one more time doing it with the user interface, and this time I'm gonna save the metadata first. Got the metadata uploaded. Name, Hashgraph. Text HTML. Let's save the JSON. Is that done? Have I saved it? Has that done anything? Save JSON, uploads. Yeah. That looks like it's been saved. Begin Hashnell inscription process. Let's see if this works. Ugh, same error. Same bloody error. Okay, we're gonna have to go down the route of doing it ourselves then. That's fine, that's not a problem. I think we might have to literally do it from the encoding it and chunking it ourselves. Now, plenty of invitations in ZS. Okay, so let's do that. We'll use this module over here, npm install, release integrity. Okay. And we can compress it over here. So I think what we want to do is basically want to use this library to compress our index.html file. Compress this, chunk it, and add it as some messages onto the Hedera consensus service. This will be a fun activity. This will be proper sort of the lowest level that you can interact with the Hedera consensus service for this HCS1 standard. So each chunk is uploaded as a message. Keep in mind that obviously does not matter. Retrieving and reassembling. Complete steps are fetch all the messages. What's up, Roy? How you doing, bro? Okay, so we have a valid memo. Does this need to be... Right, let's just give it a start. Let's give it a start. So we've got... Let's compress the file. Okay, let's give it a try. Come on. Stop messing about, Jake. Let's go npm init. So just going to initialize a project, and we're going to install Mongo db-js-zstd. Let's install that. And then we are going to be creating a index.js file. Then we're going to want to do something like this. except we're not going to want import. We're going to want const equals require okay, so we're going to be doing that, and then cannot find name buffer. Is buffer not available in Node? I thought it was. Yeah, okay, so that should be fine. Let's test this out. Compressed. Decompressed. See what happens when we do this. Okay, cool. So it's working. It is working. That's good to see. Okay, so we've able to do this. If you just joined, we're trying to take this. We're trying to take this index HTML file, which uses the HTS recursion SDK, and we're going to add it straight onto the Hedera consensus service because I'm not able to do it via the user interface. So we're going to take it here, and then we want it in base 64. So let's go. I think if we say, what is this type? That's a buffer there. So if we go dot, let's get our old friend out. Buffer to, yeah, that's it. Cool. Okay. Dot toString, and then we want base 64. Is that right? Yeah, okay. Let's see what that does. Okay, this worked. And then what happens if we turn this into, so well, if we do that toString, that should hopefully go back to the test. Yeah, it does. Okay, nice. And if we say to string base 64, oops. Okay, good. Okay, so let's now just compress this file, this index HTML file. So I'm gonna ask that to ChatGPT so that it compresses and console logs file at index.html. Saves me thinking about how to do it, or remembering how to do it. Yep. Okay. Promisify the gzip function. That seems a bit overkill, that. Why is it using different? Okay, it's because I didn't give it the whole. Let me give it the whole context. Let me do that again. But I mean, to be honest, I don't need to, but we can just use fs. Let's go there. Let's paste that. And then we want this line over here. Buffer. This is what we want. That's the code that we want. Let's delete that. Oh. And then we want to go console.log. Okay. So this Nice. This is the compressed HTML file and then converted into base64, which is what we want for this HCS1 standard file data management with Hedera Consensus Service. Next thing that we need to do is we need to format it with data, MIME type, which is image/HTML. And then we want each chunk is uploaded as a HTS keyword because the overall is okay. So data image/HTML base64. And then I think this is the data. Are there any examples of this on GitHub, maybe? Inscribe, well, that didn't work. Via Turtle Moon. Downloadable, huh. Let's try that. No, I'll do that later on. Hashinal's inscription portal. That's for numbers. Turbot Analytics, Trust Enterprise API. That's for HTS20. No, it's looking like there needs to be a bit better documentation around all of this. I can't lie. Registry should understand this format operations, ready to migrate. Oh, that's not it. That's the right one. We want. Sorry if I'm speaking quietly. I'm just mumbling to myself. I'll be a bit more clearer. Upload into HCS. Okay, how about if I do a fetch first, then I can make sure that I'm getting this inscribe logic right. So let's find a Hashinal online. Let's find a Hashinal, and then we can sort of reverse engineer it to make sure that we are doing it correctly. What's this over here? This is just the actual, yeah, that's not what we want. There's their repo. Repositories, Hashinal, HS recursion, HCS example commands. What SDK is this? Is this empty? This might be what we want. HCS example commands. Create index topic, submit message to HCS topic. Don't think this is what we want. 2 months ago. Let's see if anything in here uses this library, which is recommended. Nope. Nada. Okay. Hashgraph online. Anything? This is their hackathon submission. Maybe something in here must use HCS1. Something in here must use HCS1. Let's have a look at their source code. Chainlink API, constant create 7 topic. Base message. Submit topic message, yeah, cool. Create registration method, HCS7. No, it's what HCS7. It doesn't seem too relevant. Okay, let's go back to, we'll just find a Hashinal online, and then we'll fetch it from the mirror node, and then we will try and sort of go backwards and put it together. I want something simple though. I don't want something complex. Stick bug, link page. Is there any simple hashinals? Maybe I'll go to hash scan. I know there are a lot of hashinal NFTs. Maybe on hashinal. If anyone's got any hashinal NFT collections, that'd be perfect. Hashinal Grimm's collection. There we go. There we go. Let's do one of these. Let's take this NFT. Let's have a look at this. Boom. Let's just pick that. Here's the raw metadata, content location, HCS1. There we go. That's what we want. So if we fetch, and it's all okay. Sweet. So it's data application. Let's decode this. Base 64. Decode. Let's decode that. Great. Have I missed something? Is it because this is made up of is it something to do with the slashes here? Let's have a look back at the docs. Data. Oh, wait a second. It's the... it's not going to come up as anything meaningful anyway, because this should technically be the compressed base 64. So I think what we need to do, in fact, is just decompress it using that ZSTD standard. Data application JSON base 64. I think that's what we need to do. Let's see, that deep. Let's try that. So if we go that's the data, and we want to reverse it. So we want to go from retrieving and reassembling to display the data. The application retrieves all chunk messages from the specified topic. Chunks are sorted by their O index and based on their content. So we have O and C. Cool. And then what we want to do is we want to go concatenate the messages together, decompress the file using the ZSTD, ensure the memo of the topic matches the hash, convert the uncompressed base 64 into binary data. So we decompress first and then do it. I thought we went the other way. Okay, let's try that. So we'll decompress this. Equals away, decompress. And we want to decompress. Well, I guess we need to get that as a buffer first because that takes in a buffer. Yeah, so we want to say const buffer equals buffer dot from that takes bytes, doesn't it? From, I think maybe we can pass in a string, and then we say buffer, and then that gives us another buffer, which we can then, I guess, just see what that looks like as a string. Doubt this will work. I mean, ideally we'd be returning a, yeah, so we can't. Oh, I've missed something, I've deleted something. There we go. That's what we want. Is that everything there? That's there. That's there. Await, decompress to string. Why? Is there a? I don't think there's a. No, there is. Why is this not working? What's happening now? I don't understand why. Why is that formatting so funny? It tells me that there's some error with the formatting, but it doesn't look like there is. That's weird. Is it something to do with this string just being a bit funky? That string is causing some problems for some reason, but I don't know. Right, okay. For those of you who've just joined, we are trying to upload something to HCS using the HCS1 standard, and we are doing it totally from scratch, doing it by chunking it ourselves. But just to confirm I'm doing the chunking in the correct way, I'm trying to actually go backwards and decode the and go from decoding the source, decoding an existing hashinal, which works, decoding the existing hashinal and making sure that I'm getting the right sort of syntax. Yeah, that's the objective. So we're taking this as our example. And again, let's just go step by step. So we have the data, we've got the content, that's the data. Don't need this, don't need this. This is NFT metadata. And from this point on, this, I believe, is what we need to decompress. So we decompress the file using the ZSTD decoding library. So this is our data. For some reason, is this still working? Console.log. Hello. I don't understand why that. Maybe it's because it needs to be here. Okay, that works. All right, let's take it a step back then. So we've got, right. I don't know why it's not letting me do this data outside, but it is what it is. Right, okay, so now we're getting a different error, which is good. I always like getting different errors. So that's probably because throw new error, unknown frame descriptor. And that's being caused by line 20. The buffer doesn't like the buffer. Let's have a look online for decompressing. Or I guess I can. I have the docs up here somewhere. So, what if we put this data straight in? Is that better? Data must be a uint array. Yes, it must be a uint array. So I guess we can do string to uint array. Let's go for that. Input string is not that. Our input string is data. And let's try this uint array. I'm hoping that this decompresses the file correctly. Nope. New error, ZST unknown frame descriptor. Doesn't recognize the first 4 bytes of the frame. The data is not in the ZSTD format. There is excess data at the end of the frame. I wonder if is that because of that base 64 thing? Unknown frame descriptor. See, I've done an example of this before as well, which is what frustrates me. This is the memo structure. Right, that's the memo structure. That's me misreading the docs there. So we've got the memo. Where's the memo? No memo, because it doesn't need a memo. Right, so encoding. Before uploading, data must be formatted correctly. Entire file should be compressed using ZSTD. Plenty of implementations here. Compress file. We recommend using a compression level of 10. After compressing, the resulting data should be converted into a base 64 string. The final base 64 string should be chunked into segments no greater than 1024 bytes. That's because the 1024 bytes is the limit on the consensus message. So this is the base 64 encoded chunk, right? So we need to go from base 64. So we need to reverse it then. We need to go from base 64. And then we need to go buffer. Is there a second argument here, which is... I think this is right. I think we should put the buffer in here. Oh, not there. Still the same thing. Understanding. Yeah, okay. Just do a second one there. Okay, cool. So let's go base 64. Don't need that. Don't need that. This, if we then, do we decompress that? Do we go from, we decompress the buffer, don't we? Concatenate them all together. Decompress the file using ZTS. I don't see any reason why this shouldn't work. Ah, it does work. Okay. Idiot. Right, cool. So we've decompressed it and then we've converted it into a string. So actually we can also see now the image is another HCS thing. So we can try this out. Let's go. This one's probably multiple chunks. It's probably yeah, here we go. So in this instance, wow, there's over 130. Okay, there's bare. Okay, well, to be honest, I don't think it's necessary for us to do all of it. I think just with this, we get the correct structure. So we have, let's go back a bit. So we need to submit a message which takes this data. So it takes the index HTML, compresses it, converts it to base 64, chunks it into 1024 megabyte bytes, and then uploads that. So let's get ChatGPT to write us a little function which does it. We're going to want data. Okay, yeah, it will make sense now. It will make sense. Okay, right. Let's get old ChatGPT to do that. So I need you to create a function which one imports index.html, two compresses it using, I want it to be using that. We then want it, let's copy and paste that code as well. 3 converts that into base 64. Chunks the base 64 into chunks no more than 1024 bytes. Well, I mean, to be honest, I should just really copy and paste this. Let's do that. And then we want to, that's what we want to do really. Okay, each chunk is covered in JSON object, boom. And then for the time being, let's just then console.log the array of objects. That's all we'll need to do for now. Okay, cool. That's importing it, compressing it, converting it to base 64. Not going to need that. That's going to be a index.html. We can hard code that because that's obviously HTML. This does the chunking, make sure everything's there. And then if I equals 0, add that prefix. Cool, that's a pretty comprehensive function. Think it works. Looks like it should work. And then what we want to do is just console log it, console log, yep. Well, I'd be interested in seeing what the MIME type is. Let's run this. I don't have that library. Let's delete that, don't need it. We just want application HTML, is Is that the correct MIME type? Oh, I've got it up here already. Oh, well. So inscribe now. Text HTML. Text HTML. Text HTML. Okay. So this function should do the chunking correctly. It'd be nice if there were some utility functions which basically did all of it. But it looks like, okay, cool. So it looks like we have 10 chunks. This first chunk has data, text HTML, base 64, and then we start. So this is all that we need to upload into the Hashgraph, the Hedera consensus service. Okay, let's now do that. So we can ask ChatGPT to do it as well. Let's go to the Hedera docs. Let's have a look at the SDK for Hedera consensus service. Reason I'm doing this is just so we can give ChatGPT some proper context so it doesn't hallucinate. Okay. Great. Now we need to add some extra logic. So we need to, one, create a Hedera consensus topic. Two, asynchronously submit messages by iterating over the chunks array to the consensus service. So we do that by submitting a message using this API. Okay, cool. Oh, no, ChatGPT. Right, so assume I have already added installed Hashgraph and set up the client. Coolio. Okay, I'm gonna just add my environment variables offline. Let's install the Hashgraph SDK. I'm gonna create my environment variables in here. I also need to install .env. Gonna want a I think this is the first native Hedera stuff that I've done on this stream. So on this Hashgraph Hustlers series. So this is good. So we've got our account ID. We have our private key. Like I said, I'm gonna populate these variables offline, especially because it's going to be mainnet as well, isn't it? Yeah, I need to be extra safe for that. Let's get my details set up. Do not want mainnet keys being leaked online. Actually, for those of you who don't know how to find your private key on Hashpack, just in case you didn't, click on that 3 hamburgers accounts and then go into the account. You can then click on that view. Okay. Copy the private key. Copy the done. Dun, dun, dun. General. Okay, cool. So I've got my environment variable set up. Let's just got my environment variable set up. I have require .env .config, and then let's say const client equals client dot for testnet dot set operator, and then this is going to be process.env account ID process.env private key. This is obviously what my environment variables are called. Okay. And shut up. And hopefully by now, ChatGPT has written the rhythm. Bro, I literally said, I said, assume I've already got it installed. Why are you telling me to install it? Right, so we've got that. Let's install all of these. Sounds good. Okay. And then it looks like it's doing the transaction over here. So we've got all of that. Client, Let's do this. So I think I'm just going to copy it. I only need to copy this new stuff, don't I? Step 5, create Hedera consensus topic. Submit message. Await. Okay. Let's add this in. Hopefully it's done it right. So we have topic create transaction. We are executing it. We then get the topic ID. We're then submitting the message. The message is JSON.stringify chunk. Yep, that makes sense. In 0 indicates success. No, it doesn't. No, it doesn't, mate. Status dot underscore code. We don't want that to equal 22. 22 equals success. You moron. Did a good job though so far. So right, let's try this. I think it should be okay. Nope. Payer account not found. Bro, I'm such an idiot. I did it for testnet. It needs to be for mainnet. For mainnet. Okay. And actually, I like to have dot then console. Let's go. Process.exit 0 dot catch process.exit 1. Let's try another time. There we go. Boom. So it's creating the Hedera topic. Topic's been created. Submitting chunks. Is it doing it async? Do you know what? It's not doing it async. I said it do it asynchronously. So because if we have a look at this consensus thing, because the order is done on the metadata level, you don't need to actually do it asynchronously. So you don't actually need to do it synchronously. You can do it async. And it orders it by doing over here, but obviously the code's doing it synchronously, meaning we've got to do one at a time. What I would have preferred is if we had done this code over here, await promise.all, and then we did a map of chunks.map, and then we just say chunk, and we say submit message chunk. And actually, I think we can even just go submit message. I'm pretty sure that's all we need to do. Let's just do that because we'll see how much quicker it is. So that previous function took 1 minute 3 seconds. Let's do it this way, where we chunk it all in one go. I reckon it'll take half of the time. 6 times quicker. Or 5 times quicker. Okay, cool. Let's have a look at this consensus topic now. So if we go over here, this is our website, which is quite cool, I think. Well, hopefully. Hopefully. Ooh. That's not looking good. So it looks like it actually looks like it's maybe it's over 1024 bytes. Let's just be safe and just go for like 900. What I think's happened here is actually the chunks are actually too big. So it's probably done its own chunking. And that might, I guess, because if this chunk size, it doesn't include the JSON, doesn't include this stuff, does it? So maybe that's why. But we can try it. Let's just make the chunk size smaller. Really should have done it on testnet first, shouldn't I? But oh well. Good thing the consensus service is very cheap. So new topic ID. Server report an error. There we go. 1 out of 1. Yeah, okay. Cool. So we've got all of these, and our first one is over here. 0. Do we start with 0 or do we start with 1? How is it? C0, yeah. Order 0, I mean. Okay, that's cool. So now, I mean, I think I should be able to just do this. If this works, all praise to God. So it's not, page not found. Is it because I haven't inscribed it on the, it might be because I didn't inscribe it on the, using their UI. I'm not too sure, but I guess what we could do is, I was hoping we'd actually be able to play it on here, but page not found. It might be because it's not on the CDN. Maybe that's why. Let's have a quick look at the docs again. Inscribe. That's not what I want. Don't want that. API. Let's try this. If we go the transaction ID to check, ID, there's multiple IDs. JSON topic ID. Yeah, see, I think it's because inscription is incomplete or malformed. Oh, okay. Maybe that's the problem. Type image, text HTML, data base 64. Have I done something wrong? Have I done something wrong? Very likely. I guess what we can do is I can go back to the, if I go for one of the, if I try and scribe one of these collections, not inscribe it, if I try and view one of these collections, copy that, and then go over here. What happens when I try to fetch this? No, it still doesn't work. But again, it's not giving the. Oh, no, I've been an idiot. That's the token address. That's the token address. We want to get the topic ID. That's what we want. So let's get the topic ID for. Let's use this image ID. I'm hoping that if this works, it's probably an error on my side. If this works, yeah, there we go. But again, this was probably inscribed on KiloScribe, so yeah, it's got its own CDN. I think it should work. I think I must have made a mistake. So we can try and debug that. Probably what's happened is I've made a mistake. But that's fine. We can fix it. Right. So how do I test if I've made a mistake? I suppose I can reorder it and then console log it, and it should be our HTML. So let's go. Can use the API to fetch it. Well, look, I've got to drop off now. I'm going to be gone for about half an hour. When I come back, we're going to keep on powering at it. I really want to get this working on the website on here with our inscription ID. I'll be back in about 30 minutes. And then I also want to do some Chainlink stuff as well. So just as a little teaser, on the Chainlink side of things, we will be doing, I've got a smart contract. I've got a smart contract over here, dynamic HBAR NFT sale. And this uses the Chainlink aggregator interface. This contract address, which you're seeing here, this is the data feed which gives us the HBAR and USDC price. And essentially what we've got is we've got some logic over here which goes get latest HBAR price, convert USDC to HBAR. And what it does is it means you can price an NFT in USDC, 10 USDC, for example, and then it fetches the USDC to HBAR price, and it gives a dynamic calculation of the amount of HBAR that's needed to pay for that NFT. So obviously that's pretty good if you want to cost an NFT in a stable fiat amount. So this is all working. We're going to build out some of the functionality. We're going to look at doing some of wrapped Bitcoin and some other cool stuff. But yeah, that's what I'll be doing after I'm back as well. So I'm going to drop off now. Thanks a lot for everyone who's tuned in. I will be back again, 30 minutes or so. So I'll catch you all then. Same link, same stuff. See you in a bit.